Our first unit is electric charge. So we are going to start by looking at the charge property of matter, and we are going to begin by making a comparison to gravity and the mass property of matter. So if we look at our inverse squared law for gravity, Newton's universal gravitation given by capital G, m1, m2 over r squared, and we think about where does gravity come from in this equation? Well, it doesn't come from capital G. Capital G is our universal gravitational constant, which is the value that allows us to utilize F sub G practically, in that the capital G makes the force in newtons, which is consistent with our units of measure and standards, to allow it to be useful. So it's not fundamentally where gravity comes from. The r squared here is the center of mass to center of mass distance squared, so that's just geometry, that's just a distance, that's not where gravity comes from. So in a very real sense, we can think of the mass property of matter, those kilograms, as actually making gravity. So we're going to do a very similar thought process and logic connection here with electricity, and we're going to think of the charge property of matter that leads to electrostatic force, which we'll talk a lot about electrostatic force in this chapter, and eventually in the course the flow of charge giving us electricity. So it's this charge property of matter that we are going to attribute to really being the thing in nature that makes electricity. Now, we have two types of problems that we're going to be solving. And the one type is the discrete charge, the point particle charge. So just like we had point particle problems in mechanics, we have point particle charge problems in electricity and magnetism, and those will be our non-calculus based problems. And just like in mechanics, we had continuous mass distribution problems where we used calculus to find the center of mass of objects. We're going to have continuous charge distribution problems where we're going to look at use calculus to find the center point for the charge value. Now, as it says here, and as we've done before in physics all along, is we have variables that form equations that allow us to utilize the concepts and understand how nature works through these equations and definitions. And we also have units that go along with those variables to allow us to have a practical application and units of measures and standards to use them as well. So as it says here, our variable for charge is Q. So the little q is going to tell us how much charge is on an object. Now, the least amount of charge we can have is the charge on the individual electrons and protons that carry this charge property of matter. So large objects are made up of many electrons and protons. We'll talk more about that in a couple of moments as well. And we see that for the electron, we have a unit of charge of 1.6 times 10 to the minus 19. Now, it may seem odd to us that a unit of charge has such an odd number. We'll learn more about that later in the course. Basically, from the time of Ben Franklin and Joseph Priestley over in England, where they were doing many detailed scientific studies of how these charge properties of matter were behaving, and it was Ben Franklin who first determined that there were definitely two types of charge in matter, so two properties of matter relative to charge, and that's our electron and our proton. The electron we now designate as a negatively charged particle. We'll see why we designate it as negative as the course goes along as well, and we have our protons, which are positive. Now, one thing that's really important to keep in mind is that when an object, a macroscopic object, is negatively charged, it is because, as it says here, the object has acquired electrons. So it's only electrons that do the moving, and we have a net negative charge when electrons have moved onto an object, allowing it to have excess electrons. And an object has a net positive charge when electrons have come off of an object. So when an object has lost electrons, it has a net positive charge. Now, we also are going to note that we are not breaking up our electrons into quarks or smaller charged objects than our fundamental units of charge here, right? So we have our fundamental unit of charge will be 1.6 times 10 to the minus 19, negative for electrons, positive for protons, not smaller for us in this course. Now, these charge properties of matter, I hope you remember from chemistry. We know that like particles repel. So whether they're like negative or like positive, they repel, and opposites, the negative and the positive, attract. And it's this electrostatic attraction that is that electrostatic force that holds all of the atoms and molecules together, that hold all of the material things that we interact with together very strongly, right? They don't break apart easily, and that's a good thing. So we're going to talk more about that in a moment, but for right now, that's our introductory page of notes. So as always, pause the video, make sure you get all of your annotations completely onto the page, and we are on our way.